Welcome to this ninth video of lesson parallel lines of standard 9th mathematics part 2. In previous video we have seen how to solve sums from practice set 2.2 question number 1 to 4 based on or using the test of parallel lines. Let's see the remaining two questions from this practice set. So this is the last video of this lesson. If you want to get solution of some other questions from this lesson, let me know. Please put it on the comment box. I'll surely make video on it and upload it on the YouTube. Thank you. So let's start from question number 5. It given that say ray AE, this ray AE, this is ray AE is parallel to ray BD. This is parallel to ray BD. So these two rays are parallel. Now ray AF, this ray AF and BC bisect angle EAB. So it's given in the figure that this is XX. So this is the bisector of this angle, beta angle. This is the bisector. And this BC bisects the angle ABD. So this is the angle bisected by this way. And now we have to prove that line AF is parallel to line BC. Okay. So given these two are parallel and we have to prove these two parallel. Okay. Now here we have to use not only the test but also theorems also. Means what is the difference between theorem and the test? When it is given the lines are parallel. So when it is given say lines parallel, okay, when it is given lines parallel we can use or we can prove that, okay, we can prove that the corresponding angles congruent, alternate angles congruent, interior angles supplementary. And converse, the other situation is when it is given that alternate angles are either angles, we know about angles, that alternate angles are congruent, corresponding angles are congruent or interior angles are supplementary, then we can prove that the lines are parallel. So here we are using the theorems and here we are using the test. Okay, so this is the difference between the test and the theorem. Okay, so now here it is given to us that these two lines are parallel. So taking these as transversal, now we can see these two angles will form a pair of alternate angles. So we can say angle AEB and angle ABD, they are congruent. And if these two angles are congruent, so then this 2x, x plus x, 2x is congruent to 2y. So we can say 2x is equal to 2y. Cancelling these two, we can tell x is equal to y. So when x and y are equal, suppose we select this 2, x and y. So this pair of alternate angles, if it is congruent, then we can see these two lines are parallel by alternate angle test. So okay, so first we will use these two parallel, transversal, these two alternate angles congruent, alternate angle theorem, and making half of it, we will show this and then alternate angle test to show these required two lines parallel. This is the way we are going to do it. Okay, so let's write the proof part. So first we will write ray AE is parallel to ray BD. Why it is so? It is given to us. It's given. Okay. Therefore, angle EAB is congruent to angle ABD. ABD. We are writing alternate angles. We can skip the word theorem. Okay, these are the alternate angles. That's why they are congruent. If these two angles are congruent, means their measures are equal. As we have to make half, we can remove this congruent sign. These two angles are equal measure. And we can make half of this. Therefore, if these two angles are equal, half of these two angles should be equal. Half of angle EAB should be equal to half of angle ABD. So we have multiplied this both the angles on the left side, right side by half. And what is this half of EAB? Half of EAB we can take either EAF or FAB. But of course we will select these two angles because these two will be the alternate angle for these two lines. And therefore half of EAB we are going to take FAB. Angle FAB is equal to half of ABD. We are going to select this ABC. ABC. Why it is so? It's given that AF and BC bisect angle EAB and angle ABD. This is the reason, that's why this is the half of this, half of this. And now if these alternate angles are equal, then AF, therefore line AF, you can say it's line, just because it is given in the question. This is line AF is parallel to line BC. The reason is alternate angles congruent, hence we are using alternate angle test. Here you cannot skip the word test. This is a very important word. Don't skip this. Okay, so this way we have proved the question number 5. Now let's come to question number 6. Now in question number 6, what is given and what we have to prove? Let's see. Given it is line EF is a transversal of lines AB and CD at points P and Q respectively. Where is EF? This is EF is transversal of line AB and CD at point P and Q respectively. Ray PR and ray QS are parallel. Okay, here I have written in short, it's parallel, symbol of parallel I have used. So this is ray PR and QS, these two rays are parallel. This is given parallel and bisectors of angle BPQ and PQC respectively. Where is BPQ? This is BPQ, this angle. This is the bisector of this, and PQC. So this is the other angle. These are the bisectors. Okay. So we have to prove now line AB is parallel to CD. It is parallel to CD. So this question we can see this is exactly opposite of this. Okay. Here we have shown these two rays or lines given parallel. We showed bisectors to be parallel. Here now the bisectors are given parallel and we have to show the original lines are parallel. So exactly we have to do the similar thing. What will be little bit change over here? So as here it is, this is a parallel. So we can say these two alternate angles are congruent. Okay. If these two alternate angles are congruent, what is this bigger angle we can get? How can we get? If we multiply this smaller angle by 2, we can get the bigger angle because this is the half of the bigger angle BPQ. So if we here as we multiplied by half, here we can multiply these two angles by 2 to get this bigger angle. So if this, so in short means if this is x and this is x, so if this x is equal, the bigger angle is going to be 2x and here also this is going to be 2x. Okay, so 2x is going to be equal. So these alternate angles are equal, hence the lines are parallel. So this way we can write the proof. So here the difference is only half, full angle to half we have to go, and here half to full, that we have to go. So proof part, we have to start with this, these two are parallel. Okay, ray PR is parallel to ray QS by given. And if these two rays are parallel, taking this as transversal, these two angles are alternate. So angle RPQ, therefore angle RPQ is equal to angle SQP, or you can say PQS anyway, SPQ anyway. So reason is alternate angles, lines parallel, therefore alternate angles are equal. Now let's multiply by 2 on both sides. Therefore 2 times angle RPQ is equal to 2 times angle SPQ multiplied both sides by 2. So what is this twice of RPQ? RPQ is twice is BPQ. Therefore angle BPQ is equal to angle PQC. SPQ ka twice is PQC. PQC. It is reason is same we can write as which are the bisectors of which angles. So PR and QS. PR and QS bisect angle BPQ. BPQ and PQC. Angle PQC respectively. So this way we can write. Or you can put write a separate statement. Bisect, this is bisector. So this is twice of this is twice of this. Okay. And then you can say equal. But here this way also you can write, because the things are clear when you write this in the reason into the bracket. Now if these two alternate angles are equal, then you can say these two lines are parallel. Therefore line, if the word is line is used, use line. If it's ray, you can use ray. Line AB is parallel to line CD. Okay. Okay, this is proved by alternate angle test. Okay, this is proved. So in this way we have proved the last two questions from this practice set 2.2. As I told you before, if you want any other sums to be solved, please give me in the comment box. I'll surely try to make videos on it and I will upload it. I hope you have understood this lesson, parallel lines of standard 9th mathematics part 2. And if you liked it, please give me likes, please give me your comments. And yes, if you are not yet subscribed to the channel, please subscribe. Thank you.